Hi everyone. So today we're going to be talking about equations with variables on both sides. Now this is really if you missed class because we did do this in class today and we practiced. Okay, so they're more complicated equations when we have variables on both sides of that equal sign. Now let's just make sure we know equal means that the left side and the right side have the same value. But if it's asking you to solve each equation, then we follow our proper technique. First, we want to follow order of operations on each side of the equal sign, and then we'll balance the equation. All right, so first I'm going to distribute that 7. Now make sure we're using those arrows so that we don't forget that the 7 also has to make its way over to the 2. So that's giving me 7a minus 14 minus 6 equals. Now on this side, I see that I have like terms, so I would like to go ahead and take that extra step to combine the like terms. Now let's just remind, like terms are the same variable raised to the same exponent. Now when you add them, you only add the coefficients. You do not change the variable. So this would be 3a plus 8. All right, go back to that left side and I see that I've got two constants that I can add together. So I'm going to do a negative 14 minus 6. Noticing carefully they're both negative, so that's going to give me negative 20. Okay, how are we doing so far? Take a breath, look at that. Now we've simplified both sides of the equation, and now we can balance. Now my trick that I mentioned to some of you tend to just always go to the left side, but I always bring the smaller variable to the larger, kind of ensuring that it's always going to be positive. So I'm going to bring the negative 3a over to the 7a, and I'm doing its opposite operation. What you don't really see is there's the 3a, there's a plus in front of it. So I have to do it, to get it to the other side, I got to do its opposite. So I'm going to subtract it. Then I'm going to add the 20, and we get 4a equals 28. Now 4 is being multiplied to that variable, so now I have to do its opposite operation, which is to divide, and so a equals 7. So that is what we would call the solution set. Now, and sometimes you might even see that a teacher will put it in brackets like that for the solution. All right, that means if I plug 7 in, 4a, into this equation, it will make the equation a true statement. All right, let's try a harder one. All right, so now I've got parentheses on both sides. So again, I want to simplify both sides before I balance. So I'm going to distribute my 3 and I'm going to distribute my 2. All right, take a second and do that and let's see if we've got it right. So hopefully you got 3 minus 3x. Very careful to make sure that 3 gets to everything. Plus 5x equals 2x plus 2. Now sometimes we have a tendency on this left side to want to multiply the 3 to the 5, but remember we stop at the end of the parentheses. Now you really don't want to start bringing things over until you've combined the like terms. So on this side I see those like terms, same variable raised to the same exponent, so I'm going to do 3 plus 2x equals 2x plus 2. Okay, well, you might be noticing something. You might be noticing the variables are exactly the same. So which one to bring to which one? Well, some of you already seen what's happening here, but just in case you haven't, I'm going to subtract 2x from both sides. And boy, do I get a weird answer. 3 equals 2. So what that's telling me is that this given equation is actually a false statement. The variable disappeared, and basically in doing so, it's giving us this response that's 3 equals 2. So we would say, therefore, there is no solution, or it's a null set. No solution or null set. And the way we can write that is using a circle with a line through it. It's one of the symbols that means empty set or null set. Okay? All right, let's try another one. Oh no, Coach Fred, you gave us fractions. It is okay. There's multiple ways to handle this equation, but I looked at it really carefully and I noticed 1/3 was being multiplied to that 12x minus 21. I also noticed that 12 and 21 are factors of 3, so I decided to distribute because that actually makes it a simple equation. 1/3 times 12 gives me 4x, and 1/3 times 21 gives me 7. Now, that's also an interesting answer. 4x minus 7 equals 4x minus 7. All right, so maybe you're not quite seeing it, but what if I did go ahead and bring the 4x to both sides? That leaves me with negative 7 equals negative 7. Now, that's basically telling me that the given equation is true. It's equivalent. It's satisfying itself. It's a true statement, which means that for every real number I put in for x, the equation will be true. So when you get a response like this, it means its equation is true for every real value. And we call this the identity. The identity, anything equals itself. And negative 7 does, in fact, equal negative 7. So we would say our answer is all real numbers. All real numbers. And how do we looked at that in class? 2 lines and an R through it like that. That means all real numbers. All right. So these are 3 of the things that can happen when you're solving equations. But now, what's the difference? The difference is no solutions means there's no answer that's going to work to make this equation true. And all real numbers means that all numbers will make it true. And that's very important for you to understand the difference. All right, now what do we do if the equations are more involved? Now remember, we've been working a lot on GEMDAS, simplifying expressions. Now, GEMDAS is really used to simplify expressions. So what happens when we have equations? Well, when we have equations, we have to treat each side of the equals like an expression and then balance. So this one's more involved because there's more than just parentheses. There's also brackets, which is why we use the G for grouping. Okay, so I always want to go to the most inside first. So I'm going to start right here. I see those parentheses. I'm going to distribute my 3. All right, and then I'm going to rewrite. I want to think of the left side now, having to use tornado math, make it smaller. So I've got 3x plus 2. Those brackets are still there, 1 minus. Now 1 minus 3x. Now this 3 is a negative number, so when I distribute it 3, it's going to give me minus 6 equals 2x. Now I can't get rid of the brackets because I haven't dealt with them yet. Now, the easiest way to handle this would be now to combine everything in the brackets because we go on to the next grouping symbol. All right, so let's do that. We get 3x plus 2 bracket. I have 1 minus 6. Those are constants that I can combine. So negative 5 minus 3x. Now, could I have written that as negative 3x minus 5? Absolutely. The commutative property. All right, equals 2x. Gosh, look, we're just working with the left side. We're using proper order of operations. Catch up if you need to here. Now we're going to distribute our 2. Now we're ready to distribute our 2 because we've got the multiplication. And there's nothing in the parentheses we can do. So that leaves me with 3x, minus, because now I have 2 plus a negative 5, or 2 times a negative 5, which is negative 10, minus 6x equals 2x. Okay, so now I'm going to combine the like terms here. Just making sure that I did all my work right here. Okay, so now I'm going to combine the like terms, and I'm going to get negative 3x minus 10 equals 2x. All right, this is important for me now. This is where it's game time. I want efficiency. I don't like negatives. This is where when I balance, I always bring the smaller to the larger, and negative 3 is smaller than 2x. So I'm going to add 3x to both sides. That's making sure that my variable won't be negative. Now I know the variable's on the left side, but it doesn't matter because we've got that symmetric property that means that when I divide here by 5 and I get that negative 2 equals x, negative 2 equals x using the symmetric property also means that x equals negative 2. So both of these are perfectly acceptable answers. All right, one more thing I want to do. One more thing I want to do is I want to put this into action. Put this into action with problem solving. Problem solving. We've been problem solving. We've been writing equations. Now we're going to solve it. So it says find a number that is 38 less than its opposite. Now remember, when we write a word problem, we do not start by just writing numbers down. We start by writing a let statement. We always ask, what's the question asking us for? And it's asking us to find a number. Find a number. So we're going to let n equal the number. All right, if we let n equal the number, we read the equation, the sentence exactly as it's written. Find a number that is. So n is means equals. 38 less than. Remember, less than's a flip it around word. So I'm going to put that minus 38 in the back. It's opposite. And we spent a lot of time working on opposites. Opposites just mean negative n. All right, now we're ready to solve. Bring the smaller variable to the larger. So I'm going to bring that negative 1n to the other side by doing its opposite. I'm going to add the like terms. I get 2n equals negative 38. And then, yep, you guessed it, I divide by 2. All right, and that's going to give me n equals negative 19. All right, so hopefully this was a really helpful review, or if you weren't in class, lesson on how to handle some odd problems. Now I want you to try the textbook problems that you missed if you weren't in class. Thanks so much. Have a great day.